There it is. Okay. So CS career paths, we're continuing our CS career series. We're just kind of showing what the possible options are to go into the CS world. So yeah, let's get started. So first off, the table of contents, kind of what we're going through, what careers are doing. I guess, yeah, I can go over them. So data scientists are basically Harry Potter and the 400 gigabytes of unprocessed data. We'll be going over web developers. If you become a web developer, you'll frequently find yourself asking, how do I center this div? It's actually very hard. Desktop developers, you'll ask yourself, or you'll actually ask your colleague if you should optimize the CPU usage, and you're gonna say nah. That's why Chrome is so slow, or actually it takes up so much CPU. Embedded developers, you'll ask yourself, or you'll ask your colleague, yo, can you help me find this 20-year-old data sheet? And you actually will find it. And then if you want to be a professor or a research scientist, then, oh, someone's coming. Okay. Then you're just gonna do research, basically. All right, let's go on. So data scientists. Oh, sorry.
First of all, we have the data scientists, which we like to call glorified statisticians. So data scientists apply statistical methods to extract knowledge and actionable insights from raw data. So basically, they get a bunch of data from their computer and they try to make sense of what it means in a way that would make sense and be able to be used for the others in their company. So despite the portrayal of data science as just applying statistics and data analytics methods to data, most of their work is actually just converting raw data into a form that can be analyzed. Generally, they go through the data processing and analytics pipeline from start to finish for every project. Next slide. So for the education, although it's possible to enter the field of data scientists without a degree, it's usually better to have either a bachelor's degree in comp sci or statistics, master's degree in comp sci statistics or any relevant field, a PhD in computer science, statistics, or any relevant field as well. But of those options, a master's degree in comp sci and stats is generally the best if you're really dead set on entering data scientists and becoming a data scientist. And if you want to get a PhD in something other than CS and stats, then you should take classes in programming, scientific computing, and statistics. For skills and experiences, you need 2 to 4 years of prior experience in data analytics is usually necessary to become a data scientist. And there's a lot of skills that are needed in a lot of these fields. But the most useful for data science is programming in Python, R, and SQL, data manipulation and cleansing so that when you get the data, it'll be able to look cleaner and easily digested for others and yourself. Statistics techniques such as Bayesian and frequentist statistical methods, data mining methods, machine learning, clustering, regression, dimensionality reduction, data visualization, such as custom dashboards and Tableau, and technical writing, so you can explain to others what it actually means. So the typical work that you have to do as a data scientist, in a month, you do basically any part of the data analytics pipeline. So from securing, collecting data, cleaning up data, and performing your analysis on that data, collaborating with other data scientists, optimizing workflow and code base, and communicating with clients and managers. Then in a year, You'll be able to work with clients and managers to determine the best solution for a problem. So you get to post projects. You get to gauge executive support or sponsorship for projects and create presentations for executives so you can secure that support for project deployment.
All right, sorry. So web developers, so they're web developers, aka users of what is this number? 2,934,982 different frameworks. All right, let's get into it. So web developers, basically, they create and maintain websites and web applications. So basically any website is going to be developed by a web developer. So what they do is code, I guess, the website or web application. It tells it how to function. So when I click this, it's going to go to the next slide. Like that's something that a web developer might do. They'll be using client feedback to maintain and develop new features. So, hey, I don't like that when I go here. I don't know if you guys remember, but if you scroll, if you moved your mouse, so like this, the bottom area, like the entire thing would get occupied. But now they've like changed it to this like cleaner kind of looking thing where it's only this much, which I quite like. So that's probably come from client feedback. They maintain the website's technical aspects, so like performance and capacity. So if something new or better comes along, they're going to update that. They're going to create content for the website. They usually work in groups and individually, and they collaborate with other designers. There's actually 4 types of web developers. So there's backend, front end, full stack, and webmasters. Okay. Oh, do you guys know what each of those are, or do you want me to explain them? This one. I'll just explain it anyway. So front end is like, from my understanding, just kind of how it looks, how everything looks. Something in chat. Okay, yeah. Basically just kind of how it looks on the surface. So if I press, okay, whatever. But yeah, basically how it looks. Backend web developers kind of manage some parts of like the logic and the database stuff and like connect it to the front end. Full stack do both of these. And I'm not sure what a webmaster is. Andy, do you want to take that?
Webmasters are usually people who just manage the website and maintain it.
Cool, thanks.
Yeah, exactly. They help manage the website and they also help with updates.
So what are your education requirements? So many web developers are going to have a bachelor's degree in computer science. Again, the standard degree if you want to go into this field. You can also have a bachelor's degree in web design, digital design, IT, or graphics art. Some web devs have associate's degrees. So these can be, you can get these from community colleges. Some are very experienced and have masters in web development. And employers try to find people with experience with internet technology classes. So taking classes about IT, web programming languages, and graphic designs are going to be beneficial to you if you want to go into this career. So HTML is probably the most important programming language because that's literally what you're going to be dealing with all the time, just kind of because you're programming a website and all websites have HTML. CSS, you're probably going to be using a lot of JavaScript as well. XML, SQL, PHP, JSON are also things that you're probably going to use. So you should know tools like Flash or even other branches of JS like Node.js or React, which are increasing in popularity. Creativity skills, graphic design skills, and a personal website that like looks clean, looks good, shows that you have good front end skills. So yeah. Web developers usually have a general process workflow, so they find out what changes they need from the clients or the team members. Then they design, program, and implement those changes to create the website. So they might, in a day, they might meet with clients and managers to discuss what needs to be done in terms of functionality or design of the website. They will program and test new features like interfaces or navigation menus, logins, stuff like that. They will see how much kind of traffic their website is generating. They will write code to integrate graphics, audio, and video into the website, and help design and develop graphics to put onto the website. All right.
So now we're going to talk about desktop developers. So desktop developers basically program and write code for software applications which run on operating systems such as Mac OS, Windows, and Linux. And also they do not rely on the internet. Desktop developers help create and maintain these desktop applications, which include web browsers, apps like Microsoft Office, Adobe Photoshop, and different games too. And desktop developers usually work for large software companies, enterprise companies, which develop their own applications, and they also work for gaming companies. And desktop developers are in charge of the building, implementing, and maintaining the source code for the applications they code and create. So some desktop developers do not have professional degrees, and they basically complete online boot camps and self-teach themselves. So it's possible a desktop developer without a degree. But majority of employers for desktop developers do look for people with either a bachelor's degree in computer science or a master's degree in computer science, mathematics, software development, software engineering, or any other related major. But what is highly recommended is that bachelor's degree in computer science or any related CS field. And also you can get a master's degree in these CS fields if you would like to be promoted to like a senior desktop developer position who is more experienced. And it is recommended that you should take classes on programming principles and languages, project management, design, the structure and everything about databases, and on how computers function. And for desktop developers, you need to know some programming languages, which include Swift, C, C++, C Sharp, Python, Cocoa, Ruby, Java, and more other languages. But basically, the programming languages which desktop developers use depend on which type of applications they create and which type of frameworks they created in. So desktop developers need to be familiar with these specific frameworks like OX frameworks if you create desktop applications for the Mac system, and for like Universal Windows platform if you create applications for the if you create desktop applications for Windows platform. And desktop developers also need to have logical thinking and problem solving skills, which they use every day in their work. And employers specifically look for people who are detail oriented and patient, since this job requires a lot of patience and stresses on the details. And it's to prepare, it's recommended that you try to code and create your own desktop application before, if you're interested in becoming one. It's very helpful. And a typical work day is that desktop developers are given specific tasks to do regarding with their desktop applications. And they have meetings to discuss plans for creating these applications and setting requirements for functionality, and also basing it on client feedback. Specific tasks which the desktop developers do include testing, debugging, and documenting their code for creating the desktop applications. And they also implement testing platforms and other unit tests on their applications. And some other tasks include changing software so that it's compatible with multiple devices and frameworks. And they also implement data protection and security for their desktop applications. And others include like building reusable code and libraries, and also optimizing the existing applications for making it faster and making it better.
All right, so let's move on to embedded developers. So embedded software program developers are responsible for developing, optimizing, and maintaining the software or firmware that runs on low-level devices like microprocessors or dedicated chips for devices like laptops or refrigerators. So these types of developers often need to gain a deep understanding of the functionality of the hardware that they're working with through either reading documentation or reverse engineering the device they're working on. So most people opt for one or more of the following options: a bachelor's degree in computer engineering, computer science, or electrical engineering, or a master's degree in one of those subjects or one of those majors. And since real world experience is highly valued in this industry, doing some internships or shadowing an industry professional during the summer or during break is also highly recommended. All right, so unlike most of the careers we've covered thus far, you'll only need 1 or 2 years of experience, including internships, to enter the field of embedded development. And some of the important skills that you need are knowing how to program and and the following languages: C, C++, and assembly language, which we've covered in the compilers workshop. And you'll also need to know how to debug and test using onboard debugging frameworks. And you'll need insight on real-time operating systems and OS architecture, driver software, microcontrollers. And by the way, microcontrollers are just like mini computers, and communication protocols like I2C for serial communication and Bluetooth and Wi-Fi for long-range wireless communication. And of course, you also need to know some internet protocols like the HTTP standard, which will allow you to communicate using HTTP packets. And depending on the device you're working on, you'll need to know some cryptographic standards like the advanced encryption standard and yeah. Do you guys have any questions so far? Okay. So embedded developers' workflow is largely dependent on what their company needs to be done. So a lot of the time, embedded developers are tasked with designing new software for an embedded system. And the general workflow for doing that is reviewing the device specifications, like what application-specific hardware components are present, are there any external interfaces, any input-output devices, and so on. Next, they'll design the system architecture, like does the system operate in real time or does it do stuff asynchronously? Does an OS need to be embedded or some kind of limited OS? And what's the target power consumption or power efficiency? And after that, they'll develop the software. But before that, they need to decide what development tool chain is best suited for this system. Most embedded devices have dedicated tool chains for developing on them. And they also need to decide what programming languages they should use and what kind of program optimization they need to do. And after they develop the software, they just test using an emulator that emulates the embedded device, or they use on-chip debugging tools. All right, and the last career we'll cover for today is our professors and research scientists. So research scientists conduct and publish research in various fields of computer science, like cryptography, theoretical computer science, machine learning, programming language theory, and so on. And they're often affiliated with a company or a research lab like Google DeepMind. And professors also have the additional responsibilities of teaching undergraduate or graduate students, and optionally supervising graduate or PhD students in writing their thesis or dissertation. And as you might expect, they're hired by universities. And also, unlike most other careers, professors have the opportunity to achieve tenure, which is a contract that allows them that guarantees their salary for the rest of their career. All right, and in most cases, a PhD in computer science is required to become a professor or research scientist. And generally, all professors and research scientists should have communication and organization skills, technical writing skills for writing those research papers, and intimate knowledge of their field, which they usually gain through their PhD and writing their thesis or dissertation. And of course, research-oriented skills like best practices for writing papers and generally how the research process should work for their field. And while research scientists should have 2 to 4 years of postdoc experience at minimum. And by the way, postdoc experience is like jobs that you get after you get your PhD or master's. Since there are multiple ranks of professors, here are the basic requirements for each. So assistant professors are like professors who are just starting out. And the only requirement is a PhD or master's degree. And after you spend 5 to 7 years as an assistant professor, and you get a passing score in a holistic evaluation that the university you're working for does, you can be promoted to an associate professor. And usually at this stage, you'll have achieved tenure and your job security is guaranteed. And finally, after you spent 5 to 7 years as an associate professor and you pass another holistic evaluation done by your university, you can become a full professor, which is like what you usually think of when you think of a professor. Do you guys have any questions regarding professors or research scientists so far? Okay. So research scientists typically apply for grants or funding depending on whether their lab has funding. They train and teach their newest lab members, and they usually conduct multiple research projects at a time. And after those projects are completed, they'll attempt to publish in journals or conferences. And by the way, computer science is a unique field in that you don't just publish in journals, because conferences are where the like the newest research is usually published, and after that, you'll usually publish in a journal. And as for professors, they do everything that research scientists do, except maybe the applying for grants part. And they also teach undergraduate or graduate classes, supervise their PhD students or master students in writing their thesis or dissertation, and they can attend conferences to host guest lectures or something. So yeah.
So that's it. If you guys have any questions, put it in the chat. If there are no questions, then I think that's it. Yeah. All right. Bye. Bye, Via. You too.